All right, good morning, everyone. Let's resume here our iteration exercise that we started last class. So I guess, we talked a little bit about this, but just as a reminder, these techniques of creating functions and especially iterating over different tasks, it's something that the more complex type of data you're going to work with, the better off you're going to be by learning some of these skills. And again, we use this this example before as if you have a task that you're repeating for many different types of data sets or maybe different variables in your data, whatever that may be, if you have a repeating task that would prompt you to think, well, I'm going to just copy and paste this code and just edit that. Or maybe I'm just going to copy and paste this script and edit that for a different scenario. These are cases where especially iteration is going to help you to make the workflow more reproducible and also more efficient on your side. So we, just a quick recap of what we've done last time. So we basically brought in this data set here that was part of a paper that I co-authored, where we were using, so the student went to the field and collected 43 samples of soils and plant roots and sent those analysis for a lab to analyze for different metrics of nematode counts. So basically we came back with these 3 species of nematode and counts both in soil and roots. And these again are the acronyms that we're going to find as part of the data columns. And then on the same date, the student flew a drone with a multispectral sensor that collected data in 5 bands: the red, green, blue, infrared, and red edge. So our goal here, so first off, is going to be to calculate the vegetation indices, different ones. We already got to that point in last class, but I'm just refreshing your memory here on what we did and where we're headed. And once we have all these different response variables or predictors related to the sensor data, then we want to run regression models where for each one of the 10 nematode variables, we want to explain each one of them with one of the sensor variables for a total of 150 models. So these are many models. If you think about in class, up until this point, when we're talking about the experimental design analysis, we were running one model per class most of the time. Right now, in this class today, I hope we're going to get to the end of this script where we're going to be running 150 models. So 150 times more than what we've done up until now, but in a very efficient way. All right, so if you don't have yet, make sure you launch your 08 iteration project. You want to have that project launched. If you don't have that project launched, but you have the script open, you're in the wrong place. Make sure you open that project and launch the script from within the project. And let's just run what we've done up until now. So loading the packages, we read this data set. It had 43 rows where each row here was for one of those locations sampled on the field. And we have 18 columns to begin with, that they are most of them related to the different variables related to nematode counts. And then in the end, we have 5 columns related to the sensor data. We check the summary. We also made this density plot here to look at the distribution of the data. I'm just running this again. So we noticed mostly that the sensor data was mostly looking normally distributed, but the nematode data was looking skewed, right? So we had a lot of low values and then a few very high values in this field. Then we talked about the normalized difference vegetation index, which the default bands used in that vegetation index are the near infrared and the red. However, we can also calculate variants of this where we keep the formula, we keep the near infrared band, but we change the red band for other visible types of band from the spectrum, electromagnetic spectrum. So those would be so we also would be here the green, the blue, the red edge, and I think that would be the ones that we have at least. So because we have this overall formula that we can change the second variable here. We created a function called NDVI. So make sure you run this chunk so we have this function created in your environment. When you run that, this function should appear on your environment. And that means that is available for you to use here. So whenever we load packages, we're basically loading functions from those packages behind the scenes. They do not appear in your environment, but they're loaded in a very similar way. So this function here has 2 arguments. And then we applied that one example of running the red NDVI. So the NDVI that uses the red as the visible band by calling that function, right? So we noticed it was the same result as if we had run the by hand, I guess, formula as it would be normal. And then we created this object nematode W, where we started with nematode, our original data set. We created 4 different vegetation indices that use that NDVI function that we created, just changing the band, the visible band on that formula. And I also left you here the code for other vegetation indices that we use in that paper. We did not get into many details of these, the formula, the reasons. That's really not the goal of this class, but if you're more interested in that, you can refer back to the paper. We have all the citations there for you to look into. So make sure you run this chunk here as well. So we create all of these extra columns here related to the vegetation indices. Then we also talked about this, the fact that in R, we don't have a function that gives you coefficient of variation. We have functions that give you the mean and the standard deviation, which are the 2 pieces we need to calculate the CV. So we wrote yet another function here where, so just to, I guess, recap on this function here. So the main components that we see in any function that you're gonna run across is that function needs a name, right? So this is the name of the function. So whenever you call function name parentheses, right, this name here is that name. Every function is going to have inputs. When we're writing a function, we specify that by just naming the input here. And then we call that input in the body of the function, right? So a function name, function inputs, in this case, is just one, just X. Then we have the body of this function where we're really doing the process that you are automating with this function, or you're simplifying with this function. And then you return something, right? So there's always an output of a function. That's what you're after, is that after giving an input, allowing the function to do its work, it should return something back to you, right? So in this case here, is returning as this data frame that has the mean and the CV of X, where X is our input. It's just that variable that we are given as a vector to this function. So make sure you also run this function here, so we get that available in our environment. We did do one example here where I wanted the mean and the CV of the red NDVI column of the nematode W dataset. So we call that function here, and we got back that data frame as a mean and a CV. And I believe this is where we stopped, right? So we basically, up until this point on last class, we wrote 2 functions, one with the overall general formula of NDVI in a way that we could more easily extend that formula to other bands. And this function we just saw now to calculate the mean and the coefficient of variation for us of any given vector that you give. And by vector, I mean just, it can think of a vector as a column in a data frame. All right, so writing functions is one of the ways that we have to help us simplify code, automate code, especially if it's something you're doing a lot and you're just changing like the data frame coming in. You can always think of writing functions and being able to help you with that. So I have a few different projects where so I work with this group where we basically create reports of the USDA NASS crop condition data on a weekly basis. And I developed the script to do that, which is, I mean, it's a very complex script that has a lot of different things to it. And the first thing I had this huge script that I had to change some things here and there to get the updates of that week. And then I noticed that if I would really benefit from writing a function. So it was really, in that case, it was really interesting to me to see how, like, you have all this code that does a lot of complex things, but if you package that into a function and then you just call that function another script, it's like, it's really powerful to see how you can simplify something that is a lot of lines of code by writing a function, automating that, and just calling that function at the end. So that was, I guess, maybe the first time that I really like developed a function that was super complex and that was really simplifying so much to me at the end that it was very, very interesting to see that at play. So you can kind of think about that as well. If you have any workflow that requires multiple steps, and you're always doing the same things over and over, you can think of using functions to simplify that process. Okay, so when it comes down to iterating a function, whether that function was custom made by you or not, doesn't really matter. But every time that we have tasks that we are doing multiple times as well, using loops is going to be another way to help to automate that process. So maybe the two most popular types of loops are for loops and while loops. In my experience, I use for loops a lot more frequently. So that's the one I think we're gonna see, that you're gonna see more as well as a need as you work with more complex data. So we're gonna explore that in more detail here, the for loop in specific. So a for loop is basically going to iterate through positions in a vector and applying the same task as you move in that position of the vector. And if that doesn't sound too intuitive right now, just wait for a second. We're going to get to that, and I hope it's going to be more clear once we actually do the code. So, one example I want to give you here is, let's say that, so above we calculated the mean and the CV for one of the columns of this data set, the RNDVI. However, this data set has 28 columns, and I guess really 26 that would be of interest. We don't really need the mean or CV of site or sample ID. So let's say that I wanted to calculate the mean and the CV for each one of those columns. There are different ways we can do that, and I want to show you how we would do that using a for loop. So let's develop that understanding here. And so because we're going to be performing the same task over multiple columns of this data frame, so you can think of those different columns being different cases that we're applying the same task, where we're going to be applying that function to all of them. The function is going to return back to us the mean and the CV. And the goal of the loop is just that for each one of those columns that we give to the function, the function gives mean and CV, we just append the mean and CV results for each one of the columns in one data frame, that in the end we have just one data frame with mean and CV for each one of the columns. So that's kind of where we're going here with this example. And so, I guess just to reiterate here, so loops are going to be very useful when you are repeating the same task. So in this case here, we're repeating the task of calculating mean and CV. So that is the task we are repeating. And the different columns here are the different scenarios that we're considering. So if you're repeating a task over different scenarios, where a scenario could be a different data frame, it could be a different column, it could be anything that you think, well, I just take this out and put this other in, and that's the scenario that you're changing, but the function is doing the same thing. That's when using these loops become very useful. Okay, so I think in this code here, I was just wanted to print so we would see again that, so we have a total of 28 columns. Of those 28 columns, we really don't need a mean or CV for site or sample ID. So we're really going to start at the third column here and extract the mean and CV for all the others until the end. So the next step here, it's not a necessary step when you're doing loops, but in this case here is going to help us. So what I want to do is first create this empty data frame. You can kind of think of this as like a scaffold of what in the end I want to have, right? So in the end, I want to have a data frame that's going to have the column name, the mean, and the CV. right? So if I have 26 columns, this data frame is going to have 26 rows, where one of the columns is going to say variable name, mean, and CV, right? So I'm just going to create this empty scaffold for me to then populate with the results from the loop. So if you come here to this chunk, let's go ahead and do that. So I want to call this nematode underscore mean CV. If you give the assignment symbol, we're going to create a data frame. So let's use the function data.frame. So I want to have 3 columns here. One is going to be called variable, which is going to carry the variable name that I'm getting the mean and the CV for, and then mean, and then CV. So the first column here, we're going to give it is variable. For us to determine the length, I guess, of this data frame, what we're going to say is this column here is going to basically repeat NA 26 times because we have 26 columns we're getting the values from. So we're going to use the function rep to repeat a value. In this case here, we're repeating NA. Make sure you type that uppercase so I understand it's the actual not available. And then we're repeating that 26 times. So you can go ahead and just say rep NA 26. If you run this and we print it, this is what you're going to see. So a data frame that right now only has 1 column that's variable, and everything, it has 26 rows where they're all NAs. So we're creating, again, this empty data set that will populate with the results of the for loop. The next one, so if you come here right after the parentheses you close for the rep, you add a comma there, break code. We're going to do the same thing for mean and CV. So we're going to say mean equals to rep NA, comma 26. Get outside of that, rep parentheses, give a comma, break line. Again, say CV equals to rep NA 26 times. Let me try to extend this a little bit, so maybe easier for you to see. So make sure that you close your parentheses on the rep function, that you have commas after that parentheses. If you run it and it goes through correctly, in the end, you should have this data frame here with 3 columns called variable, mean, and CV with 26 rows, and they're all NAs. Okay, so we kind of created, so this in the end, when we finish running our for loop, this data frame here is going to be populated with the variable name, mean, and CV for each one of them. But right now, we're just creating this scaffold of an empty data frame to be populated by the loop, which we're going to do as the next step. All right, so if you come here on the next chunk, I left you some comments to kind of guide us and explain what we're doing. And we're going to develop this next chunk here as our loop. So again, what we want to do, if we just think about this in just like in plain English, right? What I want to do is, if I print our data set, which is called nematode W, I want to come, so except for site and sample ID, because those are just descriptors, they're not actual measure variables. So we're starting on the 3rd column here. I want the loop to come here, look at this column, calculate the mean CV, and give that back to me. And then those results I append on that empty data frame we just created. After doing that on the 3rd column, it changes to the 4th column. It does that, gives me the results, appends to the empty data set. Then I do that consecutively until it does that for all the columns. So in this case here, we're going to be using a for loop. The way that we specify that is beginning with the word for. So as you type that, you're going to see that it's going to change in color. That's because R understands that you're starting a loop. The way that we specify a loop is, so if you open and close parentheses, what we're going to say is for I, and normally we would say 1 all the way to the number, in this case, the number of columns, right? Because we want to iterate on column numbers. So for I in 1 until the number of calls, so the function is called endcall of nematode W. So if you think about, if you just run this little part here, that is gonna first return to you the number of columns in nematode W, which is 28. And if you run this part here, it's just gonna give you a sequence from 1 to 28. Right? So it's basically saying for a position that we are given a name of I, in the sequence from 1 to 28, do the following. In our case here, there's going to be one small change. Because of nematode W, the columns 1 and 2 are site and sample ID, and I did not want to calculate mean CV for that. Instead of starting at the position 1, we're going to start at the position 3, which is basically going to skip site and sample ID and start on mel S, which is what our numerical column is. Okay, so now you open curly brackets. It's also going to give you the closing brackets. I want you to remove the closing brackets from there and add at the end. Okay, so basically we're opening that for loop up there, we're closing down here. And now we want to say what's going to happen within this loop here. So for each position I, where I is going to range from 3 to 28, what do we want it to do? So if you think about it, the first thing that I wanted to do is to give me what is the variable name that it is calculating the mean and CV of. There's maybe a couple of ways to do that. One of them is if you come here right after this, getting the name of all columns comment, we're going to use this function here that's called call names. So we get a vector with the names of the columns. And I want to assign that to an object that I'm calling call names. So if you start typing with me, that's going to be call names, going to be the name of the object. We're going to give it the assignment symbol, and we're going to call the function that has the same name. So the function is also called call names. And then we just give the data frame that we are iterating over. So right now, at this point, what it's doing is if you just run call names nematode W, you're going to see that it's going to give you a vector with the column names by the order that they are found in the data frame, right? And then we're just assigning this to an object that's been created inside of the loop. All right, so now I have this vector that has all the column names of that data frame. Now, what I want to do is extract just the position at that first loop run for this column. So maybe let me take one step back here and tell the following. When we run this for a loop, when we finish writing it and we run it, I is going to start at 3. So it's going to say I equals to 3, and then it's going to run the function below, assuming that index of 3. Once it gets to the end of the first run, it's going to go back to the top, change I to 4. So it's going to add one number to I, rerun everything. When it gets to the end of it, goes back to the top, I becomes 5, runs everything. I becomes 6, runs everything until 28, which is the number. And that we're specifying here at this level, right? Meaning that because I named my index variable I can use that information to retrieve that I position in anything inside of this loop. What I mean by that is, so inside the loop, the first function here, or the first object that we're creating, call names, it is a series of all the column names of that data set, where this is position 1, this is position 2, this is position 3, and so on. So if for the first one here, I wanted to extract the variable name mel S. And that's because that's on the third position of that vector, and I'm calling that I. So for me to get that name, if you come here after this next comment here, so I want to create another object called var name, where var name is basically going to be this object here, call names, open and close brackets, I. So what we're doing here, let me just show you an example outside of the loop, just so we don't mess with our indexing here. So call names, I can create that because it has no indexing number. But on the first run here of this loop is going to say, we don't even have to say this because it does it automatically. I is going to be equals to 3, right? Because it's starting at 3 right there. So if I equals to 3, then this function here is basically saying call names 3, an index of 3, which is going to give you the third position of call names. So if you get the third position of call names, in this case with I equals to 3, is going to return you mel s, right? Because mel s is the third position here, 1, 2, 3, mel s, right? So this is what makes loops very powerful, is that you use an indexing variable that the loop is going to iterate over that number, always increasing in +1 after it reaches the end of the loop. And at each time that increases the number is just going to update whatever is extracting that you are setting up in the body of the loop. Any questions here? All right. So basically, the goal for this loop was to get the variable name. Now do you have a question? Go ahead.
Yeah. So I was trying to run the first part, like before the getting the name of our column, but it's giving me a, so it's not
Yeah, so the thing is,
for the part function.
so this, if you run from here, so this should run fine, because you're not, like, this doesn't have any indexing information in it. But if you run this and you did not say I equals to a number, that's not gonna work. And I'm just saying I equals to 3 here outside of the loop, just to show you what would happen in the loop. Because in the loop, we do not say this. We just allow I index to change for each one of the loops, I guess.
But my for function is also not good for the first line of the code, but this.
So once we finish writing all the loop, I mean, I guess we can, so if you were to just run this, we can go ahead and do that actually, just so you see. I mean, it's not, at this point, the loop is just, it's not gonna do much that we can see, because the only thing that the loop is doing at this point is iterating over I to change what var name is. That's the only thing it's doing right now, right? So when we get to the end here and we actually ask the loop to get var name, calculate mean CV for that var name, and append it to our empty data frame, then when we run the empty data frame, it's not going to be empty anymore. It's actually going to be populated. So that's when we're actually going to see the effect of the loop. Yeah. All right. So right now the loop is retrieving what is the var name that we're iterating over. So that we did that here. Now we want to ask it to calculate the mean and CV of that column. So the way I want to call this is I want to assign this to an object called sum for statistical summary. So this is the name of the object. Use the assign symbol. So here is where I'm going to give the function that we created to calculate mean and CV. Right, so if you go up, you're going to see that function is named mean CV. Just to remind you here, this is the function that we determined. So just coming back to the chunk again. So here I'm going to call that function mean CV. If you remember, that function only takes one argument. That's how we wrote it. That argument has to be a column with values that are going to give you the mean and CV. So the way that we're going to do that is, I know that actual column with data is inside of nematode.w, right? If I print nematode.w, that's a data frame. So I wanted to come here on the third position and get only this column here and give it to that mean CV function. So the way that we're going to do that here is just calling nematode.w, which is our data frame. And we're going to use double brackets here, and inside here we give I again. So I want to show you why we're doing double brackets and why we're giving the letter I in there. If I come outside the loop and I say I equals 3, which is going to be the first run of the loop when we actually run it. So if I say here nematode I with double brackets, it basically takes all the values under that column and gives me as a vector. In this case, the column is the third column on the nematode.w data set, which again is that mel_s. If I only use one bracket, it would give me the actual column with the column name, which is not what I want. I just want the values under that column. That's why we use double brackets. Okay, so if I say, if I then, if I do this outside of the loop where I am setting I to 3, the result of that part of the function is going to be this data frame, where it gives me the mean and the CV of that, in this case, third column in the nematode W data frame. Okay, does that make sense? So now what I want this for loop to do is not really to return to me a new data frame. What I wanted to do is to take both of these pieces of information that it calculated for the third column and populate that on my empty data frame, on the first position of that empty data frame. So I want to come here and say, this is going to become MEL-S. This is going to be the mean and the CV that you just did on the first one of the loop. So to append these results to that empty data frame that we created, we're basically just gonna, we're just gonna call the name of the data frame, which is nematode mean CV, right? That's the empty data frame that we created above. If you use the $ notation, you're gonna see that it has those 3 columns that we created. So the first thing I want to do is give the proper variable name under the variable column of the empty data frame. So we just say this equals to var name. However, if we just leave at this, what is going to happen is that it's going to assign var name, which for the first run here was MEL-S, to all the columns, or I'm sorry, to all the rows of the variable column, which is not what I want. I wanted to just assign that value here on this position. So this position here is the first position of this variable column, right? So what I would do basically would be to come here and you give double brackets and I would say I, right? So that is the position I of this data set here. Now, one complicating factor for us to think about is normally on a for loop, you would start at 1. However, in this case, we're ignoring the first 2 columns, so we're starting at 3. So if I say I here is going to start at 3, meaning that it would leave this row empty, it will leave this row empty, and it would start right here. Because of that, there is a way that we can fix it on this part of the code where I just say I minus 2, right? So the first I is going to be 3, 3 minus 2 is the first position on the nematode CV. Does that make sense? Okay. So then we're just going to repeat a very similar thing here, but just now, because right now we're just changing the variable of that data frame. We also need to assign the mean and the CV to that. So we're just going to come here, call again nematode mean CV, $ mean. So that's going to be a difference now. We want to now assess the mean column. Also using the double brackets I minus 2 notation. And then we assign here the value of the mean that we calculated. Where is that mean inside of this loop here? That mean is inside this statsnum object. And inside of it, we have the mean as a column, the CV as a column. So we would say statsnum $ mean. Then we do the same thing lastly here for the CV, right? So we want to call the nematode underscore mean CV, $ CV, double brackets I minus 2, and assign to it the value of statsnum, statsum $CV. And lastly, this is not something we need here, but I think it's useful to have a message at the end of each iteration. So you know that things are happening, right? So to ask it to give us a message, I want to call the function print. So it's going to print something to us when it gets to the end of each run. And then I wanted to say like finish running with variable name. So because I have a variable that's changing at each iteration here, we need to use a paste 0 inside here. So the function is called paste 0. You open and close quotation marks. I wanted to say finished with variable. And then I wanted to update what that variable is on each run. If you remember, we have inside of this loop here, this column called var name, which is the name of the variable at that iteration. So we can just go back here to this paste. You get outside of the quotation marks, give it a comma and say var name. So it's going to say finish with variable mel s. Is going to be what's going to happen when I equals to 3. This is our loop. Before we go ahead and run it, what I do want to do here is set outside of that loop. I want to set I to 3 and go through each one of those functions so you see what's happening on that first run when I equals to 3. So outside here, I'm setting I equals to 3. And then now I'm just going to run each one of these functions, not running at the for loop level, because if you do that, it's going to run the loop at the actual loop. I just want to go individually on these functions and see what's going on. So remember,
Bastos.
yes.
I'm sorry, I didn't know if you did this as an example or you were actually telling us to write this down. So at the very end, that the last like 3 lines of code that I assigned to 3, like, do we need to have those in our code too? I'm sorry, I think
It's
I was
up to you.
confused on
Like,
that.
you know, I just want to show you all here. If you want to follow along,
Just
you don't have to if you don't want to. It's not going to be required for you to move on the code. Yeah, but you're welcome to if you want to follow that.
okay. Sorry, I'm just making sure I had that straight.
Yeah, no, absolutely. All right, so if I set I to 3, and now I'm going to run each individual function here and see what's going on. So call names is always going to be the same because I don't have any index in it. It's always going to give me the same thing at every iteration, right? Now var name, remember, var name now on this run, I equals to 3. So if I run that and I print var name, that should have mel s, right? Now, if I run this function here, which I'm getting the mean in CV of the ith column of the nematode W data frame, and I print stat sum, it should be the mean in the CV of mel s. Now I'm going to take these 2 columns here and assign them to the I-2 position of nematode mean CV. Right now, nematode mean CV is still all empty. What these next steps are going to do are populate this position, which is I-2, 3 minus 2 equals 1. So this position of the variable column, it's going to populate this with the variable name, this with the mean, and this with the CV. So if we just run these individually, and now I print nematode mean CV, it populated the first row for us with I equals 3, right? And then when it gets to the end of this for loop, it's just going to print this message here for us, which is going to say finish with variable. Oh, I guess we can actually. So I just want to give a space here between variable and the actual variable name. We can do that either by giving a space here or by changing this function to paste instead of paste 0. I'm going to change it to paste, and then that's going to do the trick. So finish with variable mel s, right? So it did the first run with I equals 3. When it reaches the end here, it's going to go back to the top, increase I in 1 unit, run again and again and again until 28, because 28 is the number of columns on nematode W. All right. So now, and I guess just something to also keep in mind, I'm setting I equals to 3 outside of the loop just to show you how the inner works of the loop is doing. We do not have to set this when you actually run the loop, that you're not playing with it, just running it. So I'm just going to rerun here the nematode mean CV to get a blank slate for us to begin, clean slate for us to start here again. And then I'm going to come at the 4 level of this loop and just run it. If you do that, you're going to realize, because this is a very quick computation, it already finished running for every column, right? So it told you here, basically saying that it got to the end of this loop, telling you that it finished for all those columns there. So now, if you come here on the next chunk and you just print what originally was an empty data frame. Now it's gonna be fully populated with all the variable names, all the means, all the CVs. Yours not running? So you really don't need any of these here. These were just when I was showing you all. I would say take a look, compare your code with mine. You're probably missing maybe a double brackets or maybe a I index or maybe I minus 2. Is anyone having issues running the for loop? Okay. Well, maybe let's open up for a conversation then. What are you seeing, Usman? What does it giving you a specific
Yes,
error?
giving me the like incomplete expression for the for function.
Okay. So did you have here the I in 3 colon N col nematode W?
Yeah.
Okay, so let me see if anyone else has something else that maybe,
I have different if it says error in unexpected in a bracket, appending results to the empty data frame. Nematode means CV variable.
so in your case, did you run this chunk here to create the empty data frame? So make sure you run that and then come on the for loop and then run that at the top. Okay,
But on mine, I can see that it says finished with a lot of variables, but at the end, there is the error that says error in $sign, data frame, data frame, the CV. There's the asterisk EMP, I guess it's temporary, and comma CV, and then value is broken with hours.
okay. So let me do this. I'm gonna do a tour around and see here, because we have many different issues going on. I got error, object var name not found. Okay, Benita, so if var name wasn't found, make sure you're creating that object here. And that this name matches what you're assigning here. And I'll come with the online students in a second. All right.
So if you go at the top of the for loop, you just you run the code before you get the So maybe just you go to the next chunk. The next chunk you have here, you can just run this and see if that works. Yeah, so you work for. Okay, and who else is that is? Works. So it's almost like it's not seeing. This building for some reason. Oh, well, I'm good, thanks, Nico. Um. So. Is. Oh, okay, I think.
No worries. I think there's something else going on. Because you see that in learning, most of the times, it's not really kind of printing things. One way, sorry, one way with what we have. Starting away mostly mostly sometimes works. So does it normally not print?
No.
It prints. It
That
prints.
is-
It's like, it's expecting something no matter this. And I'm not sure why. It seems like. So I'm not quite sure why that's happening. We can try to troubleshoot, because I mean, you may not be able to do the next step, but you're gonna be able to do the rest. So for now, let's just do that, and let's go back to that. I mean, I can help you after class, but I'm not sure what it's gonna. Yeah, let's see.
I was missing this minus two, that's why when I was reading. But.
Okay.
Five, now I need this.
Okay, nice. That's. All right. You're good? Yeah. Okay. Okay, so Usman, I mean, looking at it, I'm not quite sure why, it's almost like it's not recognizing that you're folding this. So like right now, if you're looking at console, it is an idle, right? So it is like the greater than symbol. But when you run for loop, it's like it has a plus there, which means it's expecting something else. And I'm not sure why, because it's almost like it's not understanding that this is closing. And I'm not quite sure why that's the case. So for now, I'm just gonna escape here, so it goes back to idle, so you can keep. So it goes on idle, and just print it. I wonder. If it is empty. Yeah, so for this case here, I guess we can just wait and I'll try to help you at the end of class. All right, let's see, I have a couple of messages in the chat. I believe that I was able to produce the same output as you. Solved. Okay, so those online, seems like you all figured out. If you did not, let me know. We have one issue, we had a few issues here, that I think were probably related to brackets or things like that. One of the issues we were not able to solve But I think it may be something very specific. We'll look into later. Okay, so I guess except for Usman, everyone else was able to get to this point. So, as you can see, the loop worked, and if you, let me see here. I think we actually have, so if you run the object I just run that, you're gonna see it is 28, it's gonna print 28, because that was the last position that I took on this sequence here, right? And that's just so we can also see that the loop worked, it iterated through columns 3 to 28, given as the variable name and the mean in CV. And this is just one example of a for loop, right? A for loop, one thing you're gonna see in every for loop is gonna start like this. Most of the time it's gonna start at position 1 here, and then end at some position here. This does not have to be number of columns, it could be number of rows, for example. If you want to iterate on rows instead of columns. It's gonna do something here. So these functions here are all for our purpose, right? Nothing in here is specific to a for loop except the I, the indexing variable, right? So for loops, you need to determine the name of that indexing variable on top, and you need to use that in the body of the loop for you to know where it is in that sequence of numbers. And I is a convention. If you wanted to call this A, if you wanted to give this a name, like, I don't know, let's say position, whatever it is, you can do it, right? This is just the convention is I, but whatever you name up here is the same that you should be using here when you're calling that index. So really, the commonalities of every for loop is that they start with this sentence. You give an indexing name, you give it a sequence of index numbers, and you refer to that index name in the body of the for loop. That's what every for loop does. Any questions here about this for loop and how to use them?
Can for loop works between different files?
So Aminder is asking if for loops can work with different files. It can, right? So as long as you can iterate over those files with an index, you can do it. So what I've done in the past, let's say that I have, I don't know, weather data from an automated station for 50 sites, and I have all those each as a different CSV in a folder. You can apply, I mean, it could be a for loop, it could be other ways, but you can apply something that you first get a list of names of all the files in your data folder, and then you iterate through a loop saying read this, read that other one. So you're reading all them and creating either one object with everything that you're reading and appending, or each thing being a new object as well. We could do that. So you have to bring those files into R as objects, and that's how you would use a loop for this. And there are many examples online. If you just Google how to automate reading files in R or Python or whatever, you're gonna find examples of that. It's a really, really common task as well. So yeah. Any other questions or maybe issues you're having with the code? All right, so this, I just want to, if you've been working in Python, you're probably using a lot of loops. Yes,
I have a different table here, like I am not seeing the same table.
you're not seeing the same numbers?
Yes, I am saying 26 into 26. I am not getting this 26 into 3.
You're seeing 26 by 26?
Yes.
So what I would say is come back on recreate the empty canvas one.
Okay.
And then run again the for loop. Just to make sure you're starting clean. And if you still get 26 columns, then there's probably something different in your loop code. You're getting 26 columns. So if you're getting 26 columns, but you're starting off with 3. So your empty one has 3. And then you're ending with 26. I'm not sure how that, how that would be possible.
It must be something on the email, isn't it? So, three, four, then your stat sum, your showing. Let's just get this here, to make sure that this is returning. Yep, this is returning what you would expect. So if you're doing a total BC variable, I'm going to see equals our name. It is here. Let's start fresh. Oh, that's actually right. So we're just missing this.
Okay. Um. So. Let me just see here. I think what we can do is we can take a quick break, just because we're going to 11:30 today. I want to give you all a quick break of 5 minutes, and then we're going to come back after that to do something else using a different way of iteration, which is not going to be using loops. It's going to be using the mapping functions from the per package, from the tidyverse family of packages in R. So if you want to take 5 minutes here, we're going to be back at 10:32.
Hey, Dr. Bastos,
Yes.
when someone was talking about 26, so when I type in I, it gives me the number 28, but if I manually count like the output that I get, it is 26 number finished with variable, whatever. It prints it out 26 times, not 28.
Yeah, and that's correct, right? So what is happening there
Right.
is that I is changing from starting in 3, and the number of columns in nematode W is 28. So I is taking the values starting on 3 all the way to 28 in every 1 unit increase, right? So your last I would be 28, but then the difference that makes on the nematode mean CV is that we only have 26 rows, because if you remember, we're skipping the site and the sample ID on nematode W. We're not asking for the mean of those first two columns. Right,
Makes
so I'm
sense.
saying instead of starting at 1, which would do the mean and CV of site and onwards,
Yes, sir.
starting on 3. And that's what
Yes, sir.
something we say up here.
Thank you.
Yeah, no worries. Osman, let me take another look at your code and see if we can find.
Yeah, we'll find that.
Did you find it?
Yeah, so basically for this. It was this thing here. So it was this, so that's why. It was doing that. And it's back, it's like this, what's there, and then figure out like. After removing this, it was.
Nice.
केवल अब जन मीन किसी भी पे है हम मीन के लिए बना इस्तेमाल कर रहे हैं ओके मीन किसी भी जो स्टार्ट
All right, we are done with our 5-minute break. So let's resume things here. So if you've been working in Python, you're probably more used to, or at least have seen more loops, especially for loops in programming. In R, they are available as you see here, and they are used. But in R, there is also another way of iterating over different components of something. In this case here, those components were columns in a data frame, but they could be other types of components, as we're going to see next. So one way of iterating in R that has become very popular, most likely because it was developed by the Tidyverse team. So people at RStudio that makes all these packages that we use a lot also developed a package just to do iteration. The package is called purrr. This package here is part of the Tidyverse. So whenever you do a library Tidyverse, purrr is part of that. So maybe you're not loading purrr by itself, but it's coming through the Tidyverse family of packages. And so purrr has many functions to do iteration. This is not going to be a full tutorial on that. I want to show you the main ones that I use, at least, that I think would be the most useful for you to know as well. Just as a heads up, again, purrr has many other types of functions to iterate. And so if you would be interested, you can look online for tutorials of how to use purrr functions. You're going to find more. But I still think that the 3 main ones you're going to need and run into are the ones I'm going to show you today. So there are going to be 3 main functions here that we're going to use to iterate using the purrr package and the map functions. The first one is called map, just like that. It's not like a geographical, cartographical type of map. That is not what it means. It's more mapping a function to elements of a list. That's kind of what the meaning of that function is, where the function map by itself is going to only accept one iterating element. You can think of that iterating element like I here. So we only had one iterating element on this for loop. You could have nested for loops where you would say for I in 3. So you have this, and then you could have another for inside here saying for j in another sequence. You could be nesting multiple iterating levels in a for loop as well. But if you're just making this relationship between for loops and map functions, this our for loop that we did only has one iterating item, that's I, that's the position in the column position in that data frame. When we're using map, that is a similar concept. It only takes one iterating element, the map function. Now, if you do have two iterating elements that you want to give it, you would have to use the function map2, where you give x and y, where each one of those would be a different iterating element. And if you have more than two, and this could be any number of iterating elements, you can use the function pmap, where then you can specify any number of iterating elements in it. We're going to start simple and slow using the map function first, understand how it works, because I think it's going to be a little bit, if you've never used these functions before, the first time you see them, they are a little bit of a mind twist, because it's a new concept that we're going to check here in a moment. So because it is part of Tidyverse, it is going to be pipeable. It is going to be, you're going to include this as part of a pipe flow, kind of like what we've been doing with wrangling as well. So the way that we use those functions is you first have to define what are these groups? What are the things you want to iterate over? To do that in a pipe workflow, we're going to use the combo group by and nest. So group by is going to be where you tell what are the levels of a column that you want to do this for. So let's say you have a data frame that you did a study in 4 locations, and you have one column that says location. And now you want to run a linear model for each one of the locations separately. What you could do is copy and paste your code 4 times, just changing what is the location you're using each one of them. You could also do a for loop where I is different location. You could also use group by location and do a nest. So those would be the different ways you could iterate through that example there. So we set the groups by doing group by and nest. We're going to talk about nest in a second here, so you see what it does. And follow that with a mutate function, where inside of it, we call the function map to say, create a new column here. That's going to be maybe the linear model results that I'm doing. And I'm mapping on different levels of location for that. I know that's a lot of words that may not be making a lot of sense, but they're going to make sense in a second here. So let's actually see that in practice. In our example here, if you remember, we have 10 nematode variables and 15 remote sensing variables. My goal in the next chunk is to run all possible combinations of a single nematode variable explained by a single remote sensing variable for a total of 150 models. So I'm going to be changing what is my Y variable, and also going to be changing what is my X variable in this model. In the end, we're going to run 150 models very efficiently. And this approach is going to be a little bit of a brain twist for you, because as you're going to see shortly here, we're going to be creating data frames inside of a data frame. So just brace your horses for that. We're going to get to that in a second here. So if you get to the next chunk, we're going to start off, we're going to name this object nematode_mods for models. Let's give the assignment symbol, and we're going to start off with our data frame, which is called nematode_data. Just to print that again so you see what that is that data frame that has 43 rows, where each row is one of the sampling points on that field, and it has 28 columns that include nematode and remote sensing data. So here's the thing. For me to run these models using this approach, I have to have one column where I'm going to have, let's say, all the nematode variable names on this column, and then a second column with all the nematode values for all those names. So we have to pivot. So right now we have like 10 nematode columns. I need to pivot them longer to have them stacked and have one column saying like nematode variable, and then one column saying nematode value. Let's do that first. And maybe right now you don't fully understand why we're doing that, but it's going to make sense as we develop the code. So if you give it a pipe, remember, every time you have a data set that is in a long format and you want to make it, is in a wide format and you want to make it longer, we use the function pivot longer. We need to say first which columns we want to pivot longer. It's not all of them, it's just the nematode ones. So it has an argument called calls. And if I print nematode W, just for us to look at those columns, it's gonna be starting at mel S. So we can just type mel S, give the colon, and then say where to stop. Because they are consecutive, right? All the nematode columns are consecutive, and then all the sensor columns are consecutive after that. So we can use the colon notation to help us here. So we're starting at mel S, our last one that is a nematode column here is eggs R. So I want all the columns starting at MLS, ending in XR, and everything in between. Now I want to control how these two new columns that it's going to create, I want to control their names. So if you add a comma in that pivot longer, it has an argument called names2, and this is where you give the name of the new column that's creating that the current names are going to go into. You give a quotation mark, I want to call that resp_var for response variable. So this is what I mean by this. Also, I want to control the name of the new column where the values are going to be under. So if you give it a comma, we say values_2 is the name of the argument. I want to call that resp_val. So the values of that response variable. Remember, response variable are the y's on your formula. In our case, all of our response variables are the nematode variables. So that's why I'm calling resp for response variable. If you just run that, and we just print nematode mods to see what that is right now. So we're gonna see here site. Well, first notice that you have a lot more rows now. We had 43 originally, now we have 430. That's because we had 10 nematode columns. So 10 times 43, 430 rows that we have now. If you just keep moving here to the right, you're gonna see that on the end, you're gonna have this resp_var column where you have all the previous column headings, and then a resp_val where the values are under. So we did this for the, because in our list that we're gonna be iterating, we wanna change both Y and X on those models. That's why we're doing this. So right now we've fixed on an easy way to change the Y of the formula, which are all the nematode variables. Now we need to do a very similar approach to also do this to the X variables, which are all the sensor data. So if you come at the end of that pivot longer, you add a pipe, we're also going to pivot longer the X variables. So let's call the function pivot longer. The columns now, so calls is going to be equals to all of the remote sensing data from what we see here. So if we come back to this data set and we just look at it, the sensor data start at the column B for the blue band. So it has all the 5 bands, then all the 10 vegetation indices. So it starts at B and ends at NLI, which is the name of the last vegetation index. So we come here on calls, we say B colon NLI. I also want to control the new names of the columns. So I'd add a comma. I want to say names2. That's going to be equal to exp_var. This is because the names of those columns are going to go under the explanatory variable column. That's what I mean by exp_var, explanatory variable name, I guess. Then we give it a comma. The values are going to go under a new column that I want to call exp_val or value. So the value of the explanatory variables are going to go under this new column. Again, we're doing 2 pivot longers here because I want to change both the X and the Y on my models. That's why we're doing both. All right, if you run that and you print nematode mods right now, you're gonna have 6,450 rows where now, so site, sample ID, and yield are just repeated because those are, we did not pivot those, but we have a resp_var column with the name of all the response variables and a resp_val with the values of those response variables. If you go to the right, you have the same thing for the exp_var and exp values as well. I know this is not, the most simple way, I guess, but it's gonna make sense soon after on this next part of the code here. Okay, So hear me out. What I want to do is I want this data set that right now has 6,450 rows to only give me one row for each combination of response variable, so the Y, call the Y variables, and explanatory variable, so the X variables, right? For each combination of those, I want to have one row in this data frame. Because of that, what we can do here is group by both of those things, right? So let's go ahead, add a pipe, and then come after the comments. Let's do a group by, where it's going to be both the rasp underscore var and the exp underscore var. So if you group by those, just run it. As you remember, group by itself does not do anything, just creates a grouping structure behind the scenes. So if you just stop at the group by and you print it, it's still going to have all of your rows, but now it has this grouping architecture behind it, saying that it has 150 groups. That's because we have 10 nematode variables, 15 remote sensing variables, 10 times 15, 115 groups. All right, so now after this group by, I do want to ask you to add a pipe and call the function nest. And this is where a little bit of the magic starts. So when you use nest after a group by, and now you print it, now we have 150 rows, where each one of those rows is one combination of response variable and explanatory variable. Now, however, notice that this is where the mind twist comes the first time. So let's go slowly here. What we have now is we have this new column called data that we did not have before. We did not ask for this column to be created explicitly, but it is a result of nesting. So what nesting did is it looked at all the different levels under RESP var, it looked all the different levels under exp var, and then everything that had those common rows, it bundled into one data frame, and that data frame right now is in this cell. So this cell here, the first cell of data, or really any of the cells under data, are not just one value, they are a data frame. What I want to show you here is if you come, just for us to get an understanding now, if we come here, use a $, data, do not print it like here because it's going to overwhelm your environment. But let's just open up this cell here. So this cell is position 1 under that column, right? So let's use the colon notation here and just get that first position and run it. So if you run that, you should get this, where is a data frame with 43 rows and site sample ID and yield, but then it has these two columns here, rasp val and exp val. So these are all the Y values and the X values that we're going to run in a regression. And all these values here are coming from that first position, and that first position, rasp, the response variable is melodogeny soil, and the explanatory variable is blue. You could sample this again, any of these data frames, right? It could be any one of the 1 through 150, where they're all going to be different. They're all different combinations of whatever the response variable is, whatever the explanatory variable is. And this is kind of like that brain twist, because now you have a data frame that is nematode mods is a data frame itself, but in it, you have a column that is, each value of that column is also a data frame. So this is going to be our iterating component in the map workflow, because now I want to create a new column here that I'm going to call like linear model or something like that, where I want that for each one of these individual data frames to run a linear model, and then the resulting cell here is going to be a linear model result. So it's really this understanding here that you have an overall data frame, and under the data frame, you're going to have columns that are lists, and under those lists, you may have just a value in a given cell, but you may have a whole data frame. You may have an ANOVA result. You may have a plot, a ggplot. So this is really the flexibility that we have here with the mapping functions. Okay, any questions here? Because I know this can be confusing. So any questions at this point? All right, I'm not hearing anything, so let's keep moving. So now that I created my groups here, my iterating components, which are all the different data sets under the data column, now we're gonna actually apply a function to each one of those. So let's add a pipe here. If you come after the comment applying linear model, we're gonna have a mutate function. So with mutate, we're gonna be creating a new column here. I want that column to be called LM because we're gonna be running linear models on that column. Now, here's another difference when you have nested data frames and you're iterating in this context, is I cannot just come here and say LM and do as you would normally. I have to create a structure for that based on the function map. So call the function map. The function map is going to take two arguments. The first one of them is the name of the column that you want to iterate over. In our case, that column is called data, right? It's what was created after we nested. So if you just say data is going to be the first argument, that's where it's going to iterate over. I want you to add a comma and break code just to make it easier for you to see the next step. So the next step, we're going to give the function that we want to apply to each level of data. So that function is going to be LM. However, in the syntax that we do inside map, you have to give a tilde before that function. So tilde LM. So here's what we need to do. We need to give a Y, the name of a column that has the Y values explained by the name of a column that has the X values. I just want to print again for you here what would be the first data frame, because that would be our example, I guess. So if I go on data and get the first element, this is the data that function is going to see. Okay, so this is what the function is seeing. Which column should I put in the place of this Y? Which column should I put in place of X? Okay, so let's go first Y. So what should go under the Y placeholder here? That's going to be the resp var, or oh, sorry, the resp val, right? Remember the resp var had the names, resp val has the values. So Y here should be resp underscore val, and the X should be exp underscore val. Now, the reason why this works across all data frames is because we pivoted longer, in this case 2 times, and all the values, regardless of where the columns, all the response variable values are under, all the nested data frames have a column that is called resp val and a column that's called exp val. All of them have, even though the actual values are changing depending on what is that combination. That's how this works. All right, so if you recall on any of these functions, we need to give the data frame name, right? So let's give it a comma, just break code and say data equals to, and here's another difference. When you're using mapping functions, you do call the actual column name as the first argument. So that column name is data. Now, once you're specifying the function with the tilde that you want to apply to that column, in here, we do not say data equals data. Now this, we're going to say data equals .x. So .x is a placeholder for whatever the name of that first argument that you have. Okay, so again, on the map function, the first argument, it is the actual column name, but then on the second part of that, where you specify the function you're applying is actually .x is how you would refer to that. All right, so if you now run this, if you got the tilde there, if you got your commas right, if you made sure that data equals .x and you have your parentheses closing, it should have worked as well. Now, if you just print nematode underscore mods, which is still that object that we're assigning all of this, look at what happened now. So now you have a new column that we called LM, and the cells of that column now are not data frames anymore. They are actually LM object fit, or LM fit objects. That's the right way of saying. So if I now go under this nematode underscore mods and I call for the LM function and I sample, I guess, the first position here, this is what I get. So the power here of this approach is that you can create multiple functions that are all nested and they don't have to have the same type. One of them in this case here is the data column has data frames, the LM column has LM model fit objects. And this model fit is just specifically for this data, which is coming from these response variable and explanatory variable. And right now, you can see that we actually just ran 150 models with this. This just did 150 models for you. All right. So what I want to do next here is to extract the R square of those model fits, because my goal, yes, go ahead.
So I was thinking that when you got the model of that, it only has the coefficient that can be given, like very limited information.
So if you were to run the LM, so the linear model outside of here, it would be the same output, right? So if you were to ask for like a summary, for example, we could do a summary and get more information out of it, which we're actually going to do something like that in the next step here. So my goal on the next step, so here's my goal overall. For each one of the nematode variables, we have 15 models, one for each one of the remote sensing variables. So for each one of those nematode variables, I only want to plot and export the plot of the best model. So let's say that for Mel underscore S, the best model was with the blue band, but maybe for another nematode variable, the best model was with NDVI. I only want to keep the best model, and by best, I mean the one with the highest R square. Meaning that I have to calculate R square for this to work, right? So on the next step here, if you come and add a pipe, we're going to calculate R square for each one of these columns. So again, we're going to call the mutate function. I want to call this as R2, right? So R square. Remember, every time that you have here a nested list that you're iterating over, you do have to use the map function, right? So that's called the map function. Now you may, well, let me just print this and kind of ask for your thoughts. So if you look at what we have now, maybe even if you don't know the answer for sure, but if you had to guess, which one of these columns here would we potentially be able to use to calculate R square? LM, right? Because data itself, there's no model there, it's just a data frame. So LM is the one that actually applied a model that we get an R square from. So if you just come here, the input of this map is going to be that LM column. Give it a comma. Let's just break a line to make it easier to see. Remember that the function that you specify on the map has to be preceded by tilde, so it works. Let me show you here, maybe outside of the map, just to simplify things a little bit. So if I get here again, the first LM, this first LM here, which is the position one, if I ask for a summary of it, oh, maybe I have to do this. Yeah. So if I ask for a summary of it, this is what I get back. So part of the summary here is it has one component of the summary that is the R square. So if we give a $, it has a component called R dot squared that we can run and get the R square of that. So it does have an R square as part of that summary. All we have to do now is find a way to incorporate this as part of the map. All right, so I'm just going to copy this and paste right there after that tilde. So I'm calling the summary function. If you did not type before, you don't have to type this part that I'm highlighting right now, but you do need the summary, open and close parentheses, $ R dot squared. So if I'm given this inside of the map function, this is not going to work right? I have to delete this nematode underscore mods LM and put something else instead. What do you think should go here? Dot X? Anyone thinks it's something else? Should it be LM? Or dot X? So it is dot X, right? And that's because dot X is the way that you have a placeholder for whatever is the argument on the first part of that map. All right, so if you run this and you print again nematode mods, which is the name of the object that we're assigning all this, you have this column here called R2, and it's yet of a different type here. So it is a list, but inside of the list we have like double one, which means that it has one number there. If we just pull out this first cell here of the R square, so nematode mods $ R2, and then brackets 1, we get that R square for that regression model. Right, so we have this column here that has all R squares for all these models. One interesting thing about this approach is that we nest to create the groups, but after you did whatever you wanted, in this case here, my goal was to find the R square and select the best model, you can unnest it. So you can bring it outside of that cell that it has a different type in the data frame and bring it outside on the main data frame level. So let's do that next here on the next chunk. So I'm calling that nematode mods underscore cell or select, because here we're going to unnest the R square and just select the best model for each nematode variable. So we're going to start this here with the nematode mods, which is the object that we used above, or that we created above, nematode mods. Give it a pipe and let's unnest. So unnest, you have to provide which column you want to unnest. In our case here, I want to unnest the R2 column, which is the one that has the R square. So if you run that and you print nematode mod cell, you still have 150 rows. But notice how now that R square column is actually the actual R square value. So it went into the list and it brought out the value that was in it. We need it as a list when we created it, because that's how the mapping functions work, is you have to have a nested list of some sort. But after you calculate whatever you need, you can unnest it and bring it into the main data frame level. Okay, so now we have all the 150 models. I have all the R square values. And again, my goal is to select the best model for each of the nematode variables. To do that, just go back to the code. Let's add a pipe. How do you think we can do that? Arrange, okay, we can arrange. That would be, I mean, I guess we could go the route, but at least arrange by itself is just a visual way, right? How would you actually say for each one of these, for each value under this column, give me just the highest R square? Any other suggestions? Somebody online wrote me a comment. Filter. Okay, so Sicker, we need filter. But before that, we need something else. Go ahead, Niva. Sorry, I cannot quite hear you.
You are trying to find the maximum answer.
Yes, so you're in the right direction, right? We're going to do that. So let's go ahead and do that just to check. So if we go right now and do filter, and we can say R2 equals to the max R2, that is going to be part of it. So Sikar was saying that, Eva also mentioned that. Let's try to do that and see what happens. So if we run this and we print it, we still have 150 models. The reason for that is because we have a grouping structure that is doing this for each one of the groups that we have. So right now, our group structure is every response variable and explanatory variable. If I just want to get the highest R square for the nematode variables, which are the response variables, what am I missing here? Okay, we can go that. So I said ungroup. Let's try ungroup and see what happens. So ungroup before the filter and then add a pipe. So now we just end up with one model because it's looking at all the 150 models and just giving you the best. That's not what I want though. I want the best model for each response variable.
Maybe just ungroup explanatory and keep the response.
Okay, that's the way of thinking it. So can you think of a way to implement that in code? All right, I'm gonna help you out here. So I guess we didn't quite even, I mean, the ungroup here is helpful to understand that there was a grouping that was being affected. So we ungrouped, so we have no grouping. But really what we need here is a group by. Somebody said something, group by, yes. So Gonzalo is saying group by rest_var. That's spot on, Gonzalo. So we group by, and then if you remember here on nematode mods, I want the best R square for each nematode variable, which is under this column here. So if I group by rest_var and then filter, this should give me 10 models, or I guess 13 models in this case, because we had some models that the R square was the same for different variables. But by grouping by a rest_var and then only getting the highest R square for that rest_var specifically, we can see what were those best models. We have 10 response variables. The reason why our table ended up with 13 is because for some of them, so this would be a good case for the hat_s, there were 2 models that gave the same R square. So we're getting both of them because we're saying the best is just giving both of them because they were the same. And they were the best for that case. Awesome. All right, so we ran 150 models, selected the best, in this case 13, being the best for each one of the response variables. Now, let's say I want to plot this and export those plots. Notice how I could have plotted before filtering, but I would end up with 150 plots that I would not really care about because I only care for the plots of the best models. So first I extract the R square, filter by the best R square, and now I'm gonna make the plots. Let's promote. All right. So now I want to keep using this new object that we created where we have only the best selected models and then make some scatter plots with them. So if you come on the next chunk, let's give it the assignment symbol. So whatever we're creating now, we're gonna assign to this new object called nematode mod select plots. We're going to start off with the object that we created above. So that's the nematode mods cell. And let's give it a pipe. If you come after here, the making scatter plots with R2 in subtitle. So here's what I want to do. I want to create a scatter plot using the data column, because the data column has the rasp_val and the x_val, which are the values we want to put on the x and y axis of the scatter plots. But I want also to bring in the R square information as the title of that plot. All right. So if I just bring here nematodes mod cell, the data I need for the scatter plot is under this column. The R square I need to put in the title of the plot is under the R square column. So there are in 2 different columns. I have 2 iterating components here, right? I want to take this data, make a scatter plot, take this R square and put as the title of the plot. Because now I need 2 columns to accomplish my task, map does not work anymore. Map only works with 1 iterating component. Here we have 2. So because of that, we're going to use map2 function instead. So we still have to begin with a mutate, right? So let's do a mutate. I want to call this column as plot for a scatter plot. We give it an equal sign. Now here's where we call map2, right? So we've been calling map up until now. We're going to call map2. So the way the map2 works is you give the first iterating column, the second iterating column, and then the function. So the first here is called data, right? That's the column named data. The second one is R2. That's the column we have at the main level of the data frame, R2. Now let's give it a comma and break code just to make it easier for us to work with here. All right. Remember that inside map, map2, or pmap, when you're specifying the actual function, you need a tilde. So let's give tilde. We're going to call here a ggplot. I think now, at least from this point on until the end of this mutate, is going to look a little bit more familiar. We're going to call ggplot, where we're going to say data equals to .x, right? .x, because that is the .x position, is the first argument to give to .2. So data equals .x. I want to give it a comma and specify the AES. So AES, I'm going to have on my X column here, just to remind you. So the data is .x. What is .x? .x is going to be each one of the data frames under data, right? So if I wanted to understand what are the options I have to specify on my aesthetics, I would come here, get this, get the data, the first component of that data, and look at it. These are the columns that function is going to be seeing when it's making the ggplots. So X here is going to be one of these columns. In our case, X is going to be the exp val, right? So that's what that column is going to be. Give it comma. Y is going to be the resp underscore val. So the values of those columns. Does the order of data in R2 matter? That's a great point, Sekar, and it does. And so Sekar is asking if the order, if I say R2 and data, would that impact things? It will if you don't account for it. So the first argument you give has the position .x. The second argument you give on the map2 has the position of .y. So if we were to invert and give R2 and then data, I would have to say here data equals .y. If you do that, then it does not matter. But you have to keep in mind that they are the placeholder for them are different. So as long as you account for that, you should be good. All right, so coming after, so we close the AES, we close the ggplot. Let's add a plus. This is going to be a scatter plot. So we call geom underscore point. We don't need to specify anything in there. I do want to add a geom smooth, so a trend line for us to see how that fit looks like. So let's add a plus, geom underscore smooth. I do want to say inside here that method equals to LM, just to make sure that it runs. The smooth line is actually an intercept plus slope line instead of a loss line, which is a wiggly line. So I don't want the wiggly line. I want the intercept plus slope, and we get that by saying method equals LM. All right, so we can go ahead and run this. And if we just print the first element, so nematode mods cell plots, that's our object. $sign splot, right? So splot, well, if we just run nematode mod cell plots, now we have this new column called splots. And notice how the type of that column is a ggplot element. If I just want to show the first plot, I just do the brackets 1 and print that. This is my plot. This is what the first plot of the first cell looks like. Now, the next thing I want to do here is to actually add the R square as the title here, right? So let's go back to the code on the ggplot here, on the splot, the last mutate we were working with. You come at the end of geom smooth. Let's add a plus. To add a title, there's a couple ways that we can do that. I want to use the function labs. So if you recall, the function labs is the way you change the type, the labels of the x-axis, y-axis, title, subtitle, caption, other things. So it has here this argument for title. So you can just type that. Now, what I want to say is I want to write the words R2 colon, and then give the value of R2 that is changing. Because again, I have a string that's going to be constant, that is the letters R2 colon, and then I have a value that's going to change. I need to use the function paste 0 or paste, the ones that we use on the loop. So let's use paste perhaps. Then here we open and close quotation marks. I say R2 colon. So this is the fixed part of that. And now I give it a comma, it's still inside of that paste, and I give the R square value that is changing. Here, that R square is coming through this second argument, which we refer to in the map2 function as .y. So now if we run that, and you print your first plot just for us to inspect one of them, this is how it looks like. So now it has the title where it has the word R square, and then it gives you the R square value. Okay, so this is, I mean, we could round this R square here. I have in my code, but I'm going to skip that just for sake of time. One issue we're going to run into here is if I just print all of these plots at once, I'm not really going to know what is the response variable, what is the explanatory variable, because all of them have the same respval, expval labels. So if I come here and show you the second plot, the data is going to change, the fit's going to change, the R square is going to change, but the X and Y axis title is still the same. So what I want to do next is to actually iterate over more items. If you recall here on the main level of the data set, which is that starting one, we have the resp var and the x var columns at that level. I could bring those columns as well inside of the map function and change the title of my x and y integer plot according to those values. So then we're going to be iterating over 4 columns: resp var, exp var, data, and R square. So 4 columns that we're going to need to give to the map function to create all the plots accordingly. So let's do that as the last step here of this chunk. Let's give it a pipe and then call another mutate. So I want to call this splot underscore better, just so we know that we are improving the quality of it. Now with pmap, there's a little bit extra overhead for us to make sure it works well. So because we have 4 iterating items, we need pmap, right? Map and map2 don't work anymore here. So let's call pmap. So the way that we're gonna specify on pmap, what are the placeholder names of all these different columns, is gonna be doing the following thing. So if you are right there after the first parenthesis of pmap, let's just break code to make it easier to see. We're gonna first provide it a list. So call the function list. On this list, I'm gonna first give the name that I want of that placeholder, and then what is the column that I want to associate with that. So the first one I want to call .df. That's the name of the placeholder that I want to give it. It could be anything else. It could be df. It could be .a. I want to call .df because I think that is more intuitive. So the df, so this is going to be the placeholder for the actual data frame. The data frame, if you recall, is under the column data, right? So I say .df equals data. Give it a comma, break code. Now the next thing I want to give it is the R square. The placeholder for that, I want to call .r2. And that's going to be equals to the actual column, which is called R2. Give it a comma, break code. The next one is the response variable name. I want to call that .rv as the placeholder. And that is going to be equal to the resp var column. Well, next and last is the explanatory variable name. I want to call that .ev for explanatory variable. That's going to be equal to the xpvar column on the main data frame level. Once you finish that, so we finished giving the list and how we are referring to with the placeholders of the function that's going to come next. Give it a comma here. This next step here is just for PMAP to work. I guess this is not a lot of explanation behind it, but we need to call the function call function. And we need to just call again the name of the placeholders by themselves. So function.df, comma, .r2, comma, .rv, comma, .ev. So just calling again the name of the placeholders that we created above. After this function here, just hit return again. And this next is where we give the function that we want to apply all this to, which is going to be again ggplot. One difference here in PMAP is that PMAP does not need the tilde before the function. So what I want to invite you to do is basically to just go back to the previous ggplot, just copy all that, because we're just going to be using that as the starting point. So copy that, but leave the tilde behind. Come here after that function, paste it. And now the only difference here is that inside of the labs function, now I'm going to go there, give it a comma, break code, and I'm going to say x. So x is the argument of the labs function. I'm going to say x equals to .ev, which is again the placeholder that I created above for the expvar, which is where the explanatory variable name is. And then comma y equals .rv. That's all I need to change here to make that change happen. All right. So if you got, I know that there is like some overhead here that may be confusing, but so we start PMAP, we open a list where we give the placeholder name and then the column that represents, give commas all the way here, close the list, give a comma after the list, call this function, where inside of it, we just call the placeholder names again, break code, don't need a tilde in this ggplot. We just brought the previous ggplot here, and then we change X and Y on the labs to be those placeholders that we're bringing. If you got all that right, all the parentheses and commas and all that, this should run all right. Well, it did not in my case. Oh yeah, yes. Thanks, Ines. I'm glad that you're paying attention here, maybe more than I am. So yeah, make sure on the data you change to .df, right? Because that's the placeholder name that we had. And also on the R square here that we had .y, you change to .r2. Because again, those are what we specified up here. If you run that, yes, now it should have worked fine. So if you just come here and print this object, overall object, we have all those columns, and now we have one last column that's called the splot better. That's because we created that column with our mutate. And then if we just sample the first element of that, it's going to be a plot that has the R square on top, and then it has the response variable on the Y, and the explanatory variable on the X. Right, so now we change those labels. Now those plots, if I print all of them, I'm going to know exactly what is a Y and X. It's not going to be confusing as it was before. Okay, so we're getting towards the end of this exercise, and I don't want to rush. So I want to take one moment here and ask if anyone, I'm sure you're confused. I guess it's going to be hard to avoid that when we're doing so many complicated things at once. But any confusion that I may be able to help at this point. Right, I don't hear anything, so let's keep moving here. I guess in the next chunk, we're just printing the first plot. Do you have a question?
And
Austin, can you just hold on for a moment? I have a question here and then I'll be right back with you.
It might sound silly, but what are the?
What are the
On
the
the-
points in the plot?
Yeah.
So, okay. So Pramod is asking, what are the points in the plot? And this, we're doing a lot of advanced things here. And I would expect for you all to be confused. If you were not, maybe, I don't know, maybe you should be teaching as well. But yeah, this is all very confusing. So Pramod, for your question is, what are the points, right? So for this first plot here, right? So the first plot on this row, those points are going to be all the data between mel S and RE. To try to give you an easier visual understanding of this, if we go all the way back to the initial data set, that was nematode W, right? So nematode W was the first data set that we started that had 43 rows, right? If I did a ggplot of that, where on the X I put mel S, and on the Y I put, I think the plot here was, let me just add this on the next chunk. There was RE, right? So if I did a ggplot at that level and put mel S on X and RE on Y and did a geom point and a geom smooth with method equals LM, I got an error here. That's what that is. That's what it should be at least. Let's see. Huh, it's not exactly. Oh, yeah, that's right. So this is Y, this is X. Yeah, so now they should be the same. Yeah, so that's what that is. It's just that imagine that if you had to make this plot here for every combination, you would have to copy this 150 times, right? And we're just doing that automatically. Does that make sense? Does that help to? Yeah, but that's a really good question because yes, and I guess just an overall comment is we did the pivot longer twice because we wanted to change both X and Y. You don't have to do twice. Sometimes you may not even have to do it all, right? So let's say that if you had, again, a data set for 4 different locations and you wanted to run 2 variables, a regression between 2 columns for each location individually, you could group by location and nest. So let's say if we have 4 locations, after grouping by location and nesting, you would end up with 4 rows and their associated nested data frames, right? So we may not need to pivot longer at all in different conditions. In our case, we had just so we could have those response variable and values in specific columns. All right. Austin, you had a question?
It was just about making sure I had the plot underscore better, and then do we need to move that to where you just moved it to?
Yeah, I just moved that here so it could print that. So basically on the next chunk, I just did the printing the first splot better, just so we could see the effect of that.
Thank you.
Right. Yeah. So we have 2 more chunks here. They should be fast. I do want to say that we are at 11:29. This may take another 5 minutes. If you do have to leave now, you can do it. You're welcome to. I'm not going to take attendance right now. I will take later. If you do have to leave, just send me an email saying that you were in class and I'll take that as your attendance. But if you can remain in class, don't email me yet because we're going to have a GitHub issue for that. All right, so yeah. You mean this one here or? Yeah, I was just printing the first plot. Let's see. Yeah. I was just bringing that object name that we created, calling the splot better column, and then just printing that. All right, so let's say if I wanted to print all these plots now, because now, of course, we could still make these plots look a lot nicer if you wanted to publish. But if I'm just creating this for my visual assessment, understanding what was the best model I could create for each one of these variables, and I just want to make a plot of that, it's already in a good enough shape. So if I wanted to print all of them, we can call so the object name was the nematode mod cell plots, right? That's what we created above. If you just do $sign splotBetter and you don't provide the bracket notation, you just print that, that's gonna print you all the plots. So each plot's gonna be a panel. You can kind of go browse through them and see, what they look like. I still think this is not the easiest way for you to look at all of them at the same time. So on the next and last chunk of this exercise, we're actually going to export this plot to file in a way that's going to be easier to see. We're going to use the library Grid Extra. We're going to use that package. If you don't have that, if you run this line of code and it says you don't have that, it should be a pretty simple install.packages Grid Extra. Make sure you put Grid Extra in quotation marks if you do that, if you don't have yet this package. If you do have that, you can just load it. And what we're going to do here is call a function from that package that is called marrangeGrob. So if you just give here on this object that we're creating called all plots, give the assignment symbol. Let's just call marrangeGrob from the Grid Extra package. And in here, you're basically just gonna give the same as we did on the previous chunk, which is the name of the data frame. That's nematode mod cell plots, $sign splotBetter. So all that column there. After you say the splotBetter, let's just give it a comma, break code just to make it easier to see. And I want to change two arguments. One of them is called nRow. So I want to say nRow equals to 4. So this plot has 4, the combination of all these plots is going to be in 4 rows. And also we're going to give a comma and say ncol equals 4. So it's going to be a matrix of 4 by 4, the way it's going to fit all these plots together. If you run that and you print all plots, I think it's going to print somewhat nicely, but still squeezed. So we cannot really, here in ours, it's not really easy to see that. So let's actually go ahead and export using ggSave. So let's call ggSave. I want to say plot equals to this object that we created, all plots. Give it a comma, and we're just going to give the path, right? So if you remember, you open and close quotation marks. We need to get outside of code, so .. /. Let's navigate inside output, and I just want to call this all plots.png. If you run that, it should have exported to your output folder. So if you go there on your Files tab, click the R below button, go on output, you should have now this all plots.png object. If you launch that, now you should have one plot of all of those. So this is almost like doing a facet, but without the facet, right? So it's another way of getting multiple plots in the same page for you to look at. So I guess overall, there's really, I guess, very few of those nematode variables were properly explained by any of the remote sensing variables. We have R-squares being very low. Perhaps the highest one here that we could see was a 0.14. Yeah, so 0.14, where was the myeloidogeny on the roots explained by the SR, the simple ratio index was the best model here. So I guess overall, if we were to use bivariate models in this case, we would not be really able to explain much of what's going on with nematodes. Okay, so a quick summary here just to wrap up. So in this exercise, we created 2 functions to simplify the creation of NDVI and also coefficient variation. We learned how to iterate over with for loops and also by using the functions from the per package, which include the map, map2, and pmap. So this is a very data science-y type of topic, which is not a statistics necessarily, even though we ran a simple model. It's more like if you have something, you have to apply to a lot of things. How can you do that efficiently? These are some of the tools that you have to do that. The reason why we have this here is because we're gonna need these concepts as we move forward. So the next step that we're gonna see on Tuesday is gonna be downloading open source data for about 700 site years. Imagine now doing that by hand, one by one, you would go crazy. So we're gonna see how we're gonna use these workflows to do that, right? So that's the reason why we're looking at this. Then on Tuesday, we're gonna be bringing in this data set from open source data, using this function or these methods of iteration. And that's gonna be the data set that then is gonna feed into our machine learning part of the course. So we're gonna now start developing the data set that we're gonna be using for machine learning models to train those models when we get to that point of the course. All right, any questions before I open the GitHub issues? Right, I don't hear anything. So let me go on GitHub. Something else I wanted to tell you is, I know I'm owing you the midterm details. I want to work on that this weekend and give to you. Thanks for your patience. It's been a crazy semester, so, but I do want to get that to you soon. Also, we have in our, if you go and check our syllabus, we do have a midterm exam scheduled, or at least not a schedule, but as part of our grade. It's not scheduled yet. I want to schedule it for next Thursday, so a week from today. It's gonna involve pretty much everything up until what we can do on Tuesday. So if we finish the script on Tuesday, it's gonna be up to Tuesday. If not, it's gonna be up to today. It's gonna be, I'm still deciding if it's gonna be like on paper or on your computers. It may be on your computers just to give you some data sets and ask you to do some stuff. But it's basically gonna cover everything that we did in class, in lecture. Every lecture that we had, you should be checking that lecture as well. Those lecture materials as well, and some of the coding things that we've been doing a lot. I'm not gonna be picky and ask you something to tell me about a function that we use once, but I may come here and ask you, if I want to get the mean of this, how would you do that? What function would you use? Or maybe how would you create this model, or something that we've been doing a lot and I would expect for you to be familiar with. Those would be fair questions from my side.
What about our midterm project, Dr. Bastos?
So the midterm project is the one that you all filled out the survey that you're gonna run an experimental design analysis with your own data. That's what that is. And I need to assign you all to groups and send you the instructions for that. Okay, Benita, I can help you out after class if you wish, to help you with that issue. All right, if you already got your attendance, you're free to go. And I'll send you some more details about the project this weekend. All right.